some slight variations to that sort of thing. Okay, so difference between this and what we were doing before is now we have two different populations that we're comparing against each other, rather than a single population proportion that you're comparing against a number. All right. So instead of having like p equals 0.5, p more than 0.5, now it's p1 equals p2, p1 more than p2, and so on. All right. The either or here is really just to kind of give you a sense of the relationship between p1 and p2 in the case of the nulls, because if two things, and I'll just kind of do it off on the side, if two numbers are equal to each other, just simple algebra, very simple, you just subtract the p2 from both sides. It tells us that p1 minus p2 would have to be equal to 0. Right, so that's where that's coming from. And really, just in terms of words, what that's saying is that there is no difference between P1 and P2. All right. I talk about that because when we discuss a conclusion for something like this, we tend to use, instead of two things being equal, we tend to say that there's no difference between them, because that's how a normal person would tend to speak, even though a lot of the conclusion template seems to kind of steer away from that. Where we can, we want to try to make it sound the way a person would normally speak, but it doesn't always bear out that way. But if I were to say, like, the gas mileage between my car and your car is, the gas mileages are the same. I could do that, or I could say, yeah, there's no difference between the gas mileage in a Civic or what's the Toyota one, a Corolla, right? Like, what am I more likely going to say? There is no significant difference between the two numbers, or like the gas mileages are equal, or I'm going to say, yeah, there's no difference between the two. Right? So that's the mathematical justification for the library, or something like that. All right. So structure's the same. Calculator approach is different. We used a 1 prob z test before. Now we're going to use a 2 prob z test. Same menu though. Pretty antiquated question, but it gets the job done. A lot of these questions were written in 2003, 2004. And I just never updated them. It was a fun question back then. Now it's not overly relevant. Study was conducted to determine if the ratio of passing touchdowns to passes attempted by Peyton Manning had at this point, increased between the years of 2003 and 2004. So we got two categories. In 2003, Manning attempted 566 passes. That would be his number of trials. 29 of which were touchdowns. So 29 successes. You don't need to know what a touchdown is in order to, in the context of this situation, recognize it as a success. All right. In 2004, he attempted 497 passes, 49 of which were touchdowns. Then they tell us the alpha value. 0.05 significance level. We want to test the claim that the population proportion of touchdown passes has significantly increased. All right. So we're going to have a population proportion for the first category, 2003, and then we're going to have a population proportion for 2004. Now, I have an N for each category, and I have an X for each category. I need to distinguish between the two of them. So I'm going to give this a subscript of 1, and this set a subscript of 2. For each category, I'm going to have a population proportion P. 1 for the first category, 1 for the second category. They're asking me to determine if the population proportion of touchdown passes has significantly increased. Increased would mean that the first group is smaller than the second group. first group is smaller than the second group. If I told you a person increased in height, that would mean that their height before would be smaller than their height after. If your score increased, maybe you went from an 80 to a 90. It was smaller before than it was after. So it implies a less than symbol, which is really strange. You know, like with the explanation, it's not strange, but just in and of itself, it's like, wait, increase, less than symbol? That's a weird relationship. But if there is an increase, that would mean that the earlier value is smaller than the following value, right? And when you actually add a little context to it, it makes it sound more realistic, right? Less than symbol, fun fact, that's not an equal symbol, which means that this would have to be an alternative hypothesis, all right? The null would be the same stuff, just with an equal sign. Because we always default to status quo of an equal sign. So, 2 prob Z test. Stat. Test. Option 6. I mean, you could write test numbers down. I don't think that's necessary because as long as you know what name you're looking for, that's really the key. All right? And I think the name sort of, I don't know, I kind of look at it, it's like, well, once I really start diving into the information that's given in the problem, and then I see the name that goes along with it, I'm like, well, of course. All right, well, it's a hypothesis test, so anything that's got a test in it makes sense. Forget about the Z and the T, I don't really care about that as much as the idea that it's a prop for proportion. How do I know it's a proportion? Well, one of 2 ways. One way is a little bit more obvious. It says it right there. That's the obvious. Sometimes it won't flat out say it. If they're not talking about a mean, they're talking about a proportion. So if they don't say average, standard deviation, things like that, that kind of lingo, then we're focusing on percentages. If it's a percentage, then it's a proportion. Right? Then, if all that fails, people have done this before. I mean, it's not the most time-consuming way of going about things. But they'll go through each option and find the one that matches the information that they have. Right? Eventually, they get to this one and say, okay, this one has x1, n1, x2, n2. All right. Oh, look, x1, n1, x2, n2. Oh, wonderful. I have no idea what any of this stuff means. I do know that this is the correct function. Why? Because that's the information I have, and that's the information I need. So, for whatever reason, this is going to work. I don't care why it works. I just know that it's going to work. Obviously, why did I do that? Obviously not what I'm going for, but we'll settle for it. Type it all in the right order. You can't have more successes than trials. Or at least not often. Sorry? 6?
Wait, sorry, why does X...
Sorry, question?
Oh, never mind, my bad.
Okay.
It was
Stat test 6. The one that says 2 prob Z test. All right. So put your numbers in, hit enter on the less than option, because that corresponds with our alternative. Once we have that, hit enter on calculate, but let me just paste this in real quick. And then we get this mega menu with lots and lots of information that are useful for people that are not us. We only need one piece of information out of this. And again, the drawback is sometimes the menu has a whole lot of P in it. That sounds bad. I just want this one. The one that doesn't have a hat on it, a little triangle thing on the top of it, no subscripts, just a single P. All right? And the relationship is, again, if the p-value is less than the alpha value, then reject the null hypothesis. So my p-value, 0.00157 approximately. The alpha value, 0.05, that was given. If it's not, that's what we're using anyway, so it doesn't matter. So we ask ourselves, is that p-value less than the stated alpha value? Yes, it is. Therefore, reject your null hypothesis. And then we write our conclusion. There is sufficient evidence to reject the claim that first sentence talks about the null hypothesis. The null hypothesis is addressing equality.
What's that last variable that the calculator gives? It's like a p and then p1 and p2, and then what's the last one?
It's a p with a little hat over it.
Oh, what's that?
It stands for p hat, which is the ratio of x values over n values.
Okay.
Yeah. So, sufficient evidence to reject the claim that state the null hypothesis in words. Null hypothesis is p1 equals p2. P1 equals P2 can be thought of as having no difference between the population proportions. Okay, so that there is no difference in population proportion touchdown, what did I say, percentage? Touchdown passes, because population proportion addresses percentages. Passes between 2003 and 2004 at the 0.05 significance level. Therefore, the claim that, I don't want to rewrite the whole thing because I've already addressed a lot of that stuff. I will say the claim of an increase because now we know what we're talking about. It's increase of population proportion touchdown passes. That would be, we're rejecting the null. Okay, so the null is false, which means the alternative is true. And since the second sentence addresses the alternative, we're now saying that it is true. All right, so again, let me just kind of make this a little larger. I'll go one, no, I'm gonna go smaller. A little bit better. You think about, again, what you're actually writing down. And the answer to that is not much, because the X's and the N's are optional whether or not you're actually writing it down. I need the HO and the HA. I need the p-value, the statement of whether or not you're rejecting, and then your final conclusion. Right? This part here where you compare the p-value and the alpha value, That's pretty important, and it's required. You have to actually put that down as part of your solution because there is no evidence of numerical information unless you put that down. So in theory, and I've had people do this before, they just make stuff up on these questions completely. They'll just wing it. They know it's supposed to have P1s and P2s. They'll just guess and put a greater than or a less than symbol there. I have no idea why. And then they'll just go right to a conclusion. And they're like, okay, cool. I have no idea whether or not you even did anything in your calculator. You just wrote null and alternative and wrote the conclusion. I don't have any indication that you know anything about the material other than to say, these are my, very nice, null and alternative hypotheses and conclusions. So, yeah, you got to give me the p-value. 54 was it? I looked. I keep doing that. I look and then I don't